Hello guys, assalamualaikum. So today we're gonna discuss about ACS exam, which is this ACS exam is standardized the question like standardized question to get degree in the US. So I'm gonna explain both language Indonesia or bahasa or using bahasa or English to develop my English speech, especially particularly for chemistry subject. So yeah, we're gonna explain one by one and then try to solve for each problem step by step and then easily. Okay, kita move to first question. We are moving to first question. So there is a question about the so we are discussing about atomic structure. Okay, atomic structure. So this is the commonly part for the first discussion when we are studying about the Gen Chem 1. So the first part is mostly is about the atomic structure itself. Okay, gimana sih cara ngerjain soal-soal tentang atomic structure seperti ini? Which is kita perlu ingat dan perlu memahami, identify about definition of isotope and ion. Okay, we have to understand about isotope and ion. And then after that, we can interpret the subatomic particles. Okay, which is sangat mudah ya, sangat-sangat mudah. Karena apa? Karena kita sudah tahu tentang electron, right? Electron is kind of like in the outer layer over here. Okay, this is electron, and then as you can see, there is a neutron as well over here, and then another one is proton. Okay. So how to solve this problem is very easy as long as we understand what's the definition of isotope itself. Okay, so how to solve it? Okay, we can take a look at directly over here using the models of particles below, which are isotopes of the same element. Okay, menggunakan model partikel di bawah ini, manakah yang isotop ya of the same element. Okay, first of all, we have to understand about isotope itself. Okay, simply isotope is same number of proton. Okay, same number of proton. Okay, same number of proton, and then after that, but different. Okay, same number of proton but different numbers of neutron. Okay, so by this definition, we can solve this problem very easy. Okay, as I mentioned, as long as we understand about the definition of isotope, we can solve this problem easily. Okay, now we interpret one by one of the data. So the particle one, how many protons and then how many neutron? We don't care about the electron itself because in this equation there is no discussion about electron. Okay, electron are not considered when identifying isotopes. Okay, keep in mind, isotope doesn't have correlation for electron itself. Okay, only neutron and then proton. Okay, so for the particle one, okay, how many proton over here is 3, and the electron also as well as proton, neutron is both are 3. Okay, both are 3. Okay, particle 2, how many electron here is, we can see the how many proton is 3 as well as the neutron itself is also 3. Okay, now how about the particle 4? Particle 3, sorry. Particle 3, it consists of 3 protons, okay, and then 4 neutron. Okay, yeah. And then particle 4, how about the particle 4? It has 4 proton and then 3 neutron. Okay, 3 neutron. So by taking a look at like by this definition, same number of proton, okay, same number of proton, but different number of neutron. Okay, so particle 1 is 3 proton, particle 3 also 3 proton. However, both have different neutron. Okay, the particle 1 is 3, the particle 3 is 4. Okay, so what's the answer over here, right? What's the answer for this question? Okay, so particle 1 and particle 2. Okay, this is incorrect. Particle 2 and 4, 2 and 4. Okay, particle 2 and 4, this one with this one, which is incorrect as well. And then how about the D? Yeah, particle 3 and 4. Okay, both also incorrect. So the correct answer is P, right? The correct answer is P. So this one is the concept of the like isotope itself. Okay, concept of the isotope. Okay, so remember, isotopes is the element that has same number of proton and then but different number of neutron. Okay, all right, so yeah, we solve this problem right now, and then we moving to another question. Okay, there are 2 questions over here, and then how to solve one by one this question properly and then easily, because when sometimes we understand about the answer by memorizing, but this one is not good. We have to understand the conceptual, okay, the concept behind it, how to solve it. Okay, all right, so we're gonna do the same thing here for the second question. Okay, an atom of strontium, okay, strontium Sr 90 and 38 contains what? Okay, we want to review the concept. Okay, remember that the concept of atomic number, okay, the atomic number, all right, is number of proton. So remember, okay, atomic number itself, this one, okay, this is the atomic number. Okay, atomic number is number of proton. All right, and then another one is mass, right? Remember, mass is proton plus neutron. Okay, proton plus neutron. Okay, as you can see over here, right here, that these represent the mass. Okay, represent the mass of atom. Okay, mass number. Remember, for the top one, the top position is mass of the number, and then the below one, the below position is atomic number. Okay, so Using this concept, we can understand and then we can solve this problem very very easy. Okay, how to do it? Yeah, we can just apply this concept, right? Remember this concept very well. Keep in mind this concept very well. All right, so based on this information, okay, so the proton itself, okay, number of proton, atomic, this is the atomic this is the proton. Okay, so we can eliminate one by one for the multiple choice here. All right, this part, this answer, yeah, this choice is not good, is incorrect, right? I mean incorrect. And then how about the others? Yeah, because all of choice have like same proton, 38, 38, and 38, so we couldn't determine directly. So we have to eliminate another option over here. So for the option A, you see option A, 38 electron, right? 38 electron. Is this one correct? So you can see electron is this is proton plus neutron, and then this one is number of electron. Okay, remember if the element, or yeah, if the element is neutral, proton equal neutron. Okay, sorry, proton equal electron. Okay, so proton and electron should be the same. Okay, should be same over here because of this one. Strontium doesn't have any charge, so which is neutral. Okay, it indicates it's neutral, so it should be this one and this one same. So how about the neutron? Get how to getting the neutron? Neutron is mass. Okay, neutron is mass minus proton. Okay, mass itself is 90 minus 38, so we will ended up getting the number 52. So the answer is A. How about the option B and D? Okay, this one is good, right? But the neutron is 90, which is, if it has 90, the mass, it should be not 19. Okay, it should be not 90, kind of like this mass. So it should be 90 plus 38. Okay, 90 plus 38 if this option correct. So 90 plus 38, so the mass number, it should be 128. Okay, how about this one? This one is incorrect, and then it doesn't make any sense for this option itself. All right, so the answer is A. Okay, it's very easy, right? It's very easy to determine the like kind of like this equation. And then moving to another question, whether where we still like using, where we are still using like similar concept, using this concept, but with different kind type of the equation. Okay, so what's the atomic number for an ion that has a charge +1 and contains 18 electron? Okay, all right. So like the previous concept, we want to review again. So positive, okay, positive ion, or +1, okay, equal to atom. All right, atom lost 1 electron. Okay, remember, if the atom has positive charge, it means, okay, it lost 1 electron. Remember this concept. If the element has positive charge, it indicates this atom lost one electron. This is the concept. Okay, so therefore we know the proton, okay, the proton itself, okay, the proton, the amount of proton, it should be electron plus 1. Why? Well, like I mentioned, positive indicates the atom lost one electron. Okay, plus 1, which mean lost one electron. So for example, if we have 10 electron and then it lost one electron, it's ended up to 1, like 9, okay, 9 electrons. So how many proton? It should be still 10. Okay, it should be still 10. Okay, like I mentioned, if the atom has neutral charge, so the proton and neutron, the proton and electron should be same. Okay, so originally the neutral atom has 10, like 10 proton and 10 electron, but it lost one electron, so this atom has plus 1 charge. Okay, so it's very easy to understand this part. Okay, what is the atomic number? Yeah, back to the question. What is the atomic number for an ion that has a charge plus 1 and contains 18 electron? So based on this concept, we can understand easily, and then we can like answer very quick with this concept. Okay, so like I mentioned, it should be electron plus 1. So then the answer, it should be C. Okay, it should be C. All right, that's overall we are good right now. We can understand one by one how to solve this problem. All right, we're moving to another part, which is this part is kind of like for the next question is still the same concept like the previous one, but for the next question is like different concept again. Okay, yeah. All right, so we're moving to another question. Okay, Oke, so ya kita lanjut lagi konsep yang akan kita bahas di sini. Kita akan membahas konsep tentang masih sama ya, how many proton, neutron, and electron. Okay, so how many proton, neutron, and electron are present in as you can see Ti, okay, 22, 47, and it has plus 3. Okay, using the same concept like the previous one. Okay, I want to redraw it here. 22, 47, 3 plus. Okay, 3 plus, and then like I mentioned, this one it should be a proton. Okay, and then this one is mass, right, which represent neutron plus proton, and then this one is a charge itself. All right, so how to solve this problem? The concept to know here is, okay, like I mentioned, we can do proton first. Okay, we can do proton first. All right, so because the charge here is positive, we can understand that it lost 3 electrons. It lost 3 electrons. Okay, it lost 3 electrons. How about the proton? It's still same. It's still same. As long as the charge, okay, as long as the charge is plus, we can get the conclusion easily that the proton still same, like remain, not change. Okay, so how to solve this problem? Okay, it's very easy. So how many proton? Like I mentioned before, so it has exactly same because the charge is positive, so it should be 22. All right, so we eliminate the option C and D, and then we have remaining option A and B. Okay, how about the neutron? Right now, the neutron. Okay, the neutron is mass. Mass is 47. Okay, 47 minus 22. So the proton is 22, so 525. So both are still same, okay, which is still equal 25, 25. So we need to determine for the not one step again, one step further, okay. So plus like electron, how many electron over here? Okay, how many electron over here? So like I mentioned, electron in here, electron we can understand easily. It should be same with the neutral atom, which is 22. The normal electron is 22. If this element like doesn't contain any charge, but it contains charge over here. So how to understand this part is very easy. So 3 plus, which is lost 3 electron. So regarding this concept, we can we can get the equation like protons minus lost electron. How many electron that lost over here? So the proton is 22 and then lost electron is 3. So it should be like 19. Okay, so the answer should be A. It's very, very easy as long as we understand the concept that we already understood. Okay, so we move to another part again. So we have another part like this one is a little bit different. Okay, little bit different concept, and then it's kind of like much more difficult over here if we don't understand the concept behind it. Okay, so first of all, we need to understand the concept of the abundant stuff over here. Okay, so yeah, I will give you like a brief explanation first. Okay, we need to read the equation first. Okay, chlorine occurs naturally as a mixture of two isotopes with atomic masses of 34.97 and 36.97. What are the relative abundance of these isotopes? Okay, what are the relative abundance of these isotopes? Okay, so the concept we need to understand is the average atomic mass from the periodic table. Okay, so as the as far as I know, we will get kind of like the periodic table contain the mass of average. Okay, like average atomic mass in the periodic table. Okay, so if we are take a look at the periodic table, the average mass, okay, average mass of the chlorine itself, Cl, right, is 34.45. Okay, so using this value, using this number, we can determine the abundance of each isotopes. Okay, we can determine the abundance of each isotope. How to do that? Using the average formula. Okay, using weight average formula. Okay, for example, let X, let X is percent, percent of, the lighter isotope. Okay, remember the lighter isotope, and then divided by, and then let me explain first. So we assume this one is X. Okay, X is percent of lighter isotope, which is 34.97. Okay, from this equation. And then the other one, it should be 1 minus X. Okay, 1 minus X. How to get 1 over here? So we assume the amount itself is 1. Okay, amount itself is 1. So, and then we have like so many, for example, if we have so many isotope, we can like use assumption it consists of like 3, for example. So we can determine like X, Y, and Z. So, but over here is just 2. The first one is like we just have 2 isotopes. Okay, so we can understand X is the lighter one, and then this one like percentage for of the heavier isotope. Okay, heavier isotope, which is 36.97, right? So assume kind of like this one. Okay, assume kind of like this one. Okay, X is the lighter one, and then 1 plus 8, okay, heavier one. So like if you have kind of like the cake, and then you divide the cake kind of like this part. Okay, so and then you assume this one is 8. Okay, you assume this one is 8. How to determine this one? Is very easy, just 1 plus X. Okay, 1 plus 8. It's same concept, okay, of how to determine like how to determine the relative abundance in one, like in the isotope. So like I mentioned in this concept, in this illustration. All right, so estimate by logic. Okay, 35.45, okay, is much closer to 34, right? So then 36.97, the lighter isotope must be more abundant. Okay, must be more abundant. So this one is using the logic. So using the logic, okay. But actually it has like calculation. Okay, it has calculation. All right. Okay, so yeah, how to do that? Yeah, we can do calculation. Okay, so how to do it? Okay, remember this is our assumption. Okay, this is our assumption. Okay, using this assumption, we can do 34.97 times X. Okay, times X, and then plus, okay, like I mentioned before, this one is X plus 39.97 times 1 minus X equal 35.4. Why this one? Because it like average between both. Okay, average of both isotopes. Okay, and then we can do math solver. I mean, we can do math calculation over here to determine like X over here. Okay, so we want to determine X. Okay, we want to determine X. So how to do that? Like, okay, we can get 34.97 X and then plus 39.36.97 and then minus 39.36.97 and then 35.45, and then we move this part. Okay, we are moving this part to another side over here. Okay, so now we can ended up getting the equation like this one. It should be minus 2x. How to get it? Because this minus this one. Okay, so we get the minus 2x, and then this one, okay, and this one 35.47 minus 36.97. Okay, so and then we do calculation, we can ended up getting x is 0.76. Okay, 0.76, right? And then we can like plug this number to this equation, so like 34.97 times 0.76, and then it added up, we can get the how much it is, kind of like maybe 76. Okay, 76%. Yes, it should be. Yeah, and then for another one, how about another one for the 36.97 is very easy, just 1 minus 76, like 0.76. Okay, how to get this part? Oh, no. I'm getting messed up over here. Okay, so we assume that x is itself, right? And then this is another one. So x is x, or 34 is 94, is x itself, which is, like I mentioned, this one is 0.76. And then how about the heavier is 1 plus x, which is, we can get ended up like 0.24. So the answer is should be 76 and then 24. Okay, this one. Okay, remember we just getting the assumption of x and then 1 plus minus x. Okay, so and then we just we just do calculation some like kind of like this way, and then we getting x, and then we are getting based on the assumption that we input in the first time is x is for like the lighter isotope, and then 1 plus x is for heavier isotope. So using like do math, so we can solve this problem. It's kind of like a little bit tricky for this question because we need to understand about math little bit, but it's not bad at all. I mean, as long as we understand the basic of math, is okay for us. Okay, and then we can move to another part for the another question. All right, so we have so many questions, right? So yeah, I will like solve all of those problem one by one, step by step, and then yeah, hopefully I can like explain all of the Gen Chem materials, and then we can understand together. Alright, so we move on to another part, to another question again with the same concept of relative abundance. Okay, same concept of relative abundance. This is so important, so when we are doing for ACS exam, we can understand how to solve or tackle this issue, this question. All right, and then calculate, we need to calculate the weight, calculate a weighted average like the previous question, and then like find the average. Okay, let's do it together. Let's solve it together. Okay, the question is the element of thallium has two stable isotope, 203 thallium and then 205 thallium. Again, we are discussing about isotope. Which statement correctly describes the relationship between the relative abundance of these two isotopes? Okay. First option, percent abundance of thallium 203, like more than 205, and then yeah, well, we can do it together. Okay, so now the concept, we need to take a look at the average, like the previous concept, the average. the average of thallium itself in the periodic table. If you are seeing the periodic table, you will get the amount of the atomic mass of thallium is around 204.4 from the periodic table. And then there are two isotopes here. So thallium 203, thallium 205. So the mass itself is 203. The another one is 205. Like we are discussing before, okay, about the mass. Okay, the mass of atom, it's the top on top. In the top position. Okay, on top in the top position. Okay, it takes place in the top position. All right. So how to do that? This is the average, and then this one is the isotope. So how to abundance? Okay, how to calculate the abundance? All right. So we can answer this question just by using like reasoning method. Okay, reasoning method. Not doing any calculation stuff like the previous information, like the previous equation. No, not like that. So this one we can do calculation. We can solve this problem without doing any calculation stuff. How to do that? Okay, think logic. Okay, think logically. Like 204.4. Which one is closer? Okay, which one is closer for both condition, for both isotope? Which one that closer? You can understand that which one is closer is 200 closer to 205. Is right? Then 203. Okay, it means thallium 205 is more abundant. Okay, thallium 205 is more abundant because of what? Because which one it close? Which one it close? I give you like very very easy example. Okay, so it's very easy. It's very easy example, right? It's very easy example. So which one that closer 205, right? So we can conclude that Ti 203 is less than, okay, because it pulls the average toward its mass. Okay, the reason why, okay, because it pulls the average toward its mass. It's here is thallium 205. Okay, so the reason why the thallium 205 has like higher abundance is because of because the average like tends to like pulling towards the thallium 205. So we can understand that the over here 203 is less than. Okay, it should be less than 205. Okay, so the correct answer is C. So when we are dealing with this question, please remember you can solve this problem without doing any calculation stuff. Okay, remember the concept of that one. Okay, so we are moving to another question, another concept again. Okay, all right, we are moving to another concept. So we have another question over here. Which group number contains the most diatomic molecular elements? Okay, the concept we need to know is what's the definition of diatomic elements. Okay, diatomic okay elements is like naturally exist naturally exist, okay, as H2 molecules. Okay, or we can simply define diatomic element is it has the same atom. Okay, it has same atom and then H2. The symbol is S2, X2. I'm sorry. So for example is H2, N2, right? O2, F2, Cl2, Br2, I2. Okay. So if you are take a look at the periodic table, you will get the number like halogen group, I mean halogen group. Okay, halogen group, it have like F2, Cl2, Br2, and then I2. Okay, so which group number contains the most diatomic molecular element? So we can see that N2 and O2 also diatomic number, but it's just one. Okay, it's just one. In each group, it's just one. Okay, this is group 5. This is group 6, and then which one that the most? Which one that the most? Okay, which one that the most? It should be group 17. Okay, 17. All right, it should be group 17. Okay, if you are saying in the periodic table, it should be 17 because it contains much more diatomic number, or like I mentioned, it's halogens. Okay, periodic table. I just want to take a look at the periodic table. So yeah, 17, like 9, 17, 25, 53. Okay, and then oxygen is 8, nitrogen is 7. So yeah, and then I want to take a look at the group itself. Okay, periodic table by the group. Okay, grouping periodic table. So I want to give you kind of like the example, like this is a group number. Okay, you can see the group and then the period. Okay, the group and then the period. Okay, like, okay, I will show you over here how to do it. Okay, how to know about it. So I want to add some more. Let's see if I can give you. All right, so yeah, as you can see in the screen, right? As you can see in the screen over here, this is by grouping. Okay, so this one, 17 is over here, right? 17 is over here. Okay, so this group has so many diatomic elements. Okay, F2, Cl2, Br2, I2, and then O is 16, F is 15, and then H is 1. Okay, H is 1. Okay, all right, so we good to go. So we understand what's the point over here. All right, we go back to our slide so we can understand. So remember, group 1 is H. All right, group 16, like you can see, as you can see, 16 is before the 17, it should be O, and then this one is 15, right? And then 18 kind of like for H2 and so on. All right, so we good for this question. All right, remember for the concept. All right, so we still in the periodic table again. All right, we still see we are still in the periodic table, and then we want to solve this problem with the concept. It's again. So I just want to understand one by one, like concept one by one. We are not going through memorizing everything, but we need to understand one by one the concept behind it. So we can get more understanding, and we can get much more better understanding, and more knowledge. It's actually more knowledge, right? Okay, so move on to another part. Okay, I think I need to open the periodic table itself. Okay, because it's so important to me to understand for this. We need to understand this part properly. Okay, I need to showing again later on, so I need to showing you later on. Okay, so we move on to this question. What is the classification of sulfur? Okay, what is the classification of sulfur? Okay, concept. What's the concept we need to know? Sulfur is located in group 16. Okay, in group 16. Okay, like we know OS. Okay, OS. Okay, OS is same group. Okay, 16. Okay, element in this region are typically this is non-metals. Okay, typically non-metals, because we can see it's oxygen, and then we understand oxygen is not metal, so it should be non-metal. Okay, and then sulfur, we understand sulfur. It's kind of like type of a gas, right? Sulfur, and then sulfur is not metallic. Okay, not metalloid, and then not conductor itself as well. So yeah, all of them has the option metal, semiconductor. No, not the conductor. It's different kind of like silicon. Silicon is Si. Okay, Si is different with the S itself. Okay, remember, silicon is different. Okay, silicon is different. So based on our knowledge, this one should be non-metal. It's very easy. Okay, it's very easy. As long as we understand the concept of the periodic table, it's very easy to answer this question. Okay, and then alright, so we move on to another part right now. Yeah, we move to another part right now. Alright, so we move on to this formula. Alright, so we can use the periodic table like I mentioned, because they will provide it for us, the periodic table in the ACS exam. So we don't worry about if you don't remember all of them, but we can still see it in the exam. If the formula of ionic oxide of element X is X2O3, what's the formula of the chloride of X? Okay, what's the formula of the chloride of X? How to solve this problem? Okay, how to solve this problem, this question? The concept is use oxidation state. Okay, oxidation state. Right? To find the charge. And then how to get it based on the periodic table. As you can see, like FCl and other stuff, it should be -1, right? And then O, the coefficient is -2, and so on. And then for nitrogen, and this one, it should be -3, and then so on. So remember this concept. Okay, so if the formula of ionic oxide of element X is X2O3, okay, X2O3, what is the formula of the chloride of oxide? Okay, so over here we understand that this one is -2. Okay, it has oxidation. If it has like -2 charge. Okay, -2 charge. Okay, so if we know the amount of, like, how many oxygen here it's 3, right? So we can understand the total charge of this one is -6, based on time, just time 3 times 2, -2. All right, And then over here, it should be, it has two elements. Okay, it has two elements. So because there is no charge over here, so we need to like neutralize this element. So this is -6. Okay, so how to get this element to be zero charge? Okay, so it should has +3. Okay, it should have +3. It should has total positive charge from 2x or x to 3, right? Okay, so now find the chloride. Okay, chloride itself, it has -1. Okay, chloride itself is -1. So based on this information, we can understand. Okay, so this egg, it has +3. Okay, it has the charge, x has a charge of 3. So x3 plus 3. So while Cl is -1. Okay, why Cl is -1? So we can understand from here that egg is it can be 1, and then Cl should be 3 because of what? This is -3, and then this is +3. Okay, so the answer is should be A. Why this one is not correct? Because this is -1, this one +3 is not natural. Okay, how about this one? It's same. This is 9. Okay, this one is -1. How about this one? This is -6, and then this one is just +3. So it's not natural for all of them. Okay, so to be natural, and to be has to have zero values or zero charge, we have to have the same amount of charge for each element. All right, so the answer is should be A. Okay, we almost done. We almost done all of the question right now. So we can do some of practice over here. Okay, so we already solved like 1, 2, 3, 4, 5, 6, 7, 8, and then 9 questions. Okay, 9 concept. And then we are moving to another part. So this is kind of like practice for us to be more, I mean, to get more understanding. Okay, to get more understanding. All right, so we can do it together again, right? So I will continue off my discussion when we done for all of this part, and then we continue for another material. So hopefully I can cover everything. Okay, everything. I promise, because I have to do it. I promise. All right. So now we are practicing the real question of ACS exam, how to solve of each part. All right, so now we have another question. Let's start from back to basic. Okay, let's start with the basic. Okay, first we read the question first. Which term best describe the relation of hydrogen to deuterium, which is both are have different kind of mass, right? The hydrogen has 1, the deuterium is 2. Okay, so now we need to understand the concept behind it. The hydrogen 1 has 1 proton and then 0 neutron. Okay, and then deuterium has 1 proton and then 1 neutron. one neutron. So like I mentioned before, okay, like I mentioned before, hydrogen, the mass itself is proton plus neutron, right? And if we just have one, if we have just one, it means we need to sacrifice for the neutron. Okay, we need to eliminate the neutron. So one proton, zero neutron, and then for deuterium it has two. Okay, it has two mass, so it should be one proton and then one neutron. Okay, good. And then we let me check my email first. I want to take a look at some information. Might be there's information that important to me. All right. Okay. All right. Okay. So yeah, we can go through for another. I mean, we can go through this the first question. Sorry. All right. So we're moving to another question right now. So yeah, how to solve this problem? Let's start with the basic first. Okay. Let's start with the basic first. Okay. We are good. We have this concept right now, and then they both have same number. Okay, same number of proton but different kind of neutron. Okay, so like what we are understood from the previous question, like the I think the first or the first question about the isotope. So remember, the isotope itself is, okay, the isotope itself is, it has same proton. Okay, it has same proton, it has same, I mean the same number of proton, okay, but different neutron. So okay, so that's the very definition of isotope. Okay, based on this concept we can understand it has same proton and then different kind of neutron. All right, so it should be isotope. All right, so and then another question, number 2. Which pair represent isotope? To find isotope, we look for, okay, to find isotope, we look for, okay, same proton, again, right? And then same proton, and then different neutron. Different neutron. What's the meaning of different neutron? Okay, it should be, for same proton, it should be same atomic number, right? And then different neutron, it should be different number of neutron, which mean different mass. Okay, all right. Okay, it's pertaining mass for neutron, it's but a proton, it's pertaining atomic number. All right, let's analyze the option one by one. So how about the A option? A option, it has same weight, like same mass. It should be not, it should be different mass. Okay, it should be different mass, right? It should be different mass. And then again, we have to take a look at one by one. How about the option B? The option B, same element. Okay, same atomic number. Okay, same atomic number. 92, right? Same atomic number. And then how about the How about the mass? The mass itself is different, right? 235 and 238. This one should be isotope. How about the option C? The option C, like the previous one, but as you can see, the A option is not isotope. It has same mass, yeah, and then but different of the atomic number. And then for this one, it has both has same mass and then different atomic number. So only B option that exactly same with the definition. I mean exactly same with the definition of proton. All right, that's good. And then please, okay, we can go through another question right now. A pair of isotope has, okay, a pair of isotope has, we already understood, okay, the same number of proton, okay, that's true, and different number of neutron, that's true, okay, that's true, it's already correct, okay. And then how about this one, the same number of proton and neutron? Nope, right? Nope, but different number of electron. This is the definition of ions, okay. This is the definition. This describes this describes ions, not isotopes, okay. This definition is for ions. The same number of proton and the same number of neutron. If same number proton and neutron, which mean is identical, is exactly same, identical. So the same number of neutron and the same number of electron. Again, not how isotope are defined, so it doesn't matter for others. So you can see the isotope concept is very important over here. So when we are dealing with the concept, like we are dealing with the question about the isotope stuff, we can using this concept, okay. Hopefully we can use this concept. All right, and then now we are moving to another question again. How many neutron, okay, how many neutron are in 13C? All right, so how to do it? As you can see that neutron, okay, C is 13, okay, C is 13. Let's break this down first, okay. This is the isotope 13C, has the mass of that one is 13, okay. The mass, it has a mass number of 13. And then carbon, remember, carbon always has 6 proton, always has 6 proton. Carbon always has 6 proton. If you are take a look at the periodic table, it will be easier for us to recognize why it should be 6 proton, okay. If you are take a look at the in the periodic table, you will see in the group 6, right? 6, okay. It will be in the 6, so it will have like 6 proton, right? 6 proton, okay. Remember of this part. All right, and then for N, it should be have like 7. O, it should be has kind of like 8, and so on. All right, so to find off the electron, okay, to find off the electron, or neutron, the question is about neutron. So we can do calculation that mass, okay, subtract proton from mass, okay, subtract proton from mass. This is mass, so proton plus neutron. How to get the neutron? Subtract proton from mass, okay. Proton is 6, mass is 13. It should be so wait, yeah, it should be minus, this is plus, okay. Mass, it should be 13, and then proton itself is 6, so it should be 7. It's very easy. So remember, okay, C has 6 proton, and then N it has like 7, O has 8, and so on. All right. Number 5. In all neutral atoms, there are equal numbers of, like I mentioned, should be proton and electron. Okay, should be proton and electron. Okay, let's review what makes an atom neutral. Okay, neutral which mean, okay, no overall charge. And then this happens when, okay, the positive and are balanced. Okay, the positive are balanced with the negative charge. Okay, so the correct answer is should be D, right? Okay, this is very easy, right? It's very easy. And then we move on to another question again. All right, so which element represented by 36, 32 X? Okay. All right, how to do it? We need to take a look at the periodic table again. Okay, let's decode, let's break it down first of the symbol. Okay, 32 is represent the atomic number. Okay, is the atomic number. Okay, so number of proton. And then use the periodic table. Okay, use the periodic table with the 32 proton. Okay, with the 32 number, like atomic number 32, we can understand this one. It should be germanium. Okay, if you are taking a look at the periodic table, it should be 32. Okay, we are moving. I can show you the periodic table over here. Why not showing up over here? Oh, why is not showing up? Yeah, this one. Yeah, this one, right? So as you can see, germanium. Where is the germanium? This one, the germanium. Yeah, germanium is okay. 32, right? 32 proton. The number of the atomic number 32. See, itself is 32. Remember, atomic number represent the proton. Okay, represent the proton. So like I mentioned, if you, this one is 6, 7, 8, 9, 10, it's proton itself. Okay, it's proton itself. So don't be confused. All right, and then let's go for another question. Which statement is true? The nucleus of atom contains neutron and electron. No, electron, it should be like in the outer layer. I mean, in the outside, not in the nucleus. All right, so electron orbit outside. Okay, outside of the nucleus. So remember this, the concept. Okay, remember the concept. So I just want to throw the concept itself. So kind of like this one. So electron, it should be here, like this very traditional illustration, right? Very traditional illustration. And then in the nucleus, it contains proton and neutron. Okay, all right, so the option A is incorrect. How about the option B? The atomic number of element is the number of proton in one atom. Yeah, the atomic number of an element, atomic, remember, like this one, atomic number, it represents the proton itself. Yes, that's good. The mass number of atom is the mass number the mass. What is that one? Okay, mass proton plus neutron. Okay, proton plus neutron. It's incorrect, right? It's incorrect. I mean, it should be mass is proton plus neutron, but here is the number of proton plus the number of electron. No, it's incorrect. It should be proton plus neutron, not proton plus electron. Okay, the number of electron outside the nucleus is the same number of neutron in the nucleus. No, it should be so. It doesn't. Only true in some rare case, not a rule. Okay. All right. So the correct answer it should be B. Which atom has the most neutron? Which atom has the most neutron? Okay. Which atom has the most neutron? All right. How to deal with this question? Okay, we will subtract atomic number. Okay, we will subtract atomic numbers proton, which is proton, right, from the mass number. Okay, the mass number to get the neutron. Okay, so we need to do it one by one. Okay, now it's neon 20. Neon 20. Okay, so 20 over here, it's represent the mass. Okay, represent the mass. 20 here is represent the mass. Remember, this one is represent the mass. Is 20. So like I mentioned, to get the neutron, we need to subtract the neutron, the proton atomic number from the mass. Okay, so 20 subtract, like we need to subtract atomic number 10, which is neon is the atomic number is 10, right? So we need to take a look at the periodic table. I will show you later on. 20 10. Okay, so it should be 10. And then how about the phosphorus? 23 times minus 11 15, it should be 17. Chlorine 35 minus 17, right, should be 18. And then sulfur 35 minus 16, it should be 19. So this one is the most neutrons. Okay, the most neutron. If you are take a look at the periodic table, as you can see over here, why is not showing up over here? All right, so like we mentioned about neon. Okay, number 20, neon number, the mass is should be 20. Okay, should be 20. I need to get the bigger version. Okay, so we need to know the number 10. Okay, neon is 10. Okay, see over here, this is 10. So in the equation, neon 20, which mean it the weight. Okay, the weight here is 20. Okay, the mass of that atom should be 20. And then as you can see, the proton itself is 10. So to get the neutron, like I mentioned, mass equal proton plus neutron. So to get the neutron, okay, to get the neutron should be mass minus proton. Okay, to get the mass, mass minus proton. Okay, should be 10. Okay, 20 minus 10, it should be 10, and so on. So you can use this periodic table, right? During ACS exam, they will provide it for us. Okay, so this one, neutron. Okay, I already changed this part to neutron, not the neutron. We need to find out the neutron. Okay, we move on to another part again. I think this is the last question for us today. So we're gonna like discuss again after all of those things done. Okay, later on, inshallah. Okay, we move on to another part. How many neutrons are here? Okay, let me prepare it first so we can understand easily. All right, so let's continue. How many neutrons are in 37, like chlorine, or over the element of chlorine? Okay, Cl 37 and 17 is very easy. It's very easy. Okay, as long as you understand the concept. This one is proton, right? Okay, this one is number, like the mass. Okay, the mass number is 37. How to find out mass number is proton plus neutron. So to get the neutron, it should be mass minus proton, right? Minus proton. Okay, so kind of like this one. So it should be 37 minus 17. It should be 20. So the answer, it should be 20. Okay, which pair of particles has the same number of electrons? Okay, strategy. Okay, count electron by adjusting for charge. What's the meaning of that? Okay, electron is atomic number minus positive or plus negative. This is the equation. Okay, remember, electron is atomic number minus positive or plus negative. Okay, how to do it? How has the same of electron? Okay, let's evaluate. Let's review one by one for the option. For F minus, okay, it has it adding one electron. Okay, it adding one electron. This is the negative, right? So plus, so atomic number plus negative, which means F is like atomic. How about the atomic number of F? We can take a look at in the periodic table. So it has 9. Okay, and then by using this equation, we can understand if the charge, the amount of charge is negative, so we use the positive here, and then if the charge is positive, we use minus over here. So 9 plus 1, so it should be 10, and then Mg2 plus, it should be, here is minus, so remember like the opposite sign between both. So for Mg is like 12, and then minus 2, it should be 10 again. So the answer is already correct, like match for the A option. How about the B1? The B1 is Na, is Z is 10, right? And then the electron is 18. Okay, the electron is 18. Okay, so Z is 10 electron, and then Na is 10, and then R is 18, so it's different electron. And then how about the C? The C is Br minus. You know, Br has the has the proton, has the number, the atomic number 35. Okay, Br minus is 35. So if this one is minus, it should be plus 1. It should be 36. And then for SE, it should be 34 over here. Not match. And then how about S is okay. And then for how about the Al 3 plus? So Al normally without charge, it should be 13, and then it is plus, it should be minus, and then 10 again. But how about the P3 minus? If P normally has 15 without charge, and then if has like 3 plus, it should be 3 minus, it should be plus 3, it should, and then ended up 18. So both are not matching, not same. So the final answer recap here is it should be A for the question number 10. All right, that's all. I will continue for another explanation for another question. But still in same topics about atomic structure stuff. All right, bye bye. See ya.